The shear force at any point along the beam is the total forces acting perpendicular to beam longitudinal axis up to the point. The bending moment at any point along the beam is equal to the area under the shear force diagram up to that point. For a simply supported beam, the bending moment at the ends will always be equal to 0. In this experiment, our objective is to determine the shear force and bending moment at the particular section and compare with the theoretical calculation.
This experiment is to study about shear force variation at cut section due to variation of load and variation of load position. In this experiment, we are going to use a structure frame in the laboratory. Then, to demonstrate the concept of how to conduct this experiment, this is how we set up the apparatus. This is the cut section. This is point A, B, C, and D. First, we place a load between A and B. Then, we record the experimental shear force value. Then a higher load is replaced. Next, replace by placing the load between B and D, and also C and D. Then, a graph of measured shear force with the position applied load was plotted. First, by using measured shear force from the previous part, we draw a shear force diagram for all cases, and this is how a shear force diagram looks like. Then, measured shear force at section XX was obtained from the shear force diagram and compared with the measured value.
In order to calculate the shear force due to uniform distributed loading, we had to apply 3-point loads of the same magnitude, and they are placed next to one another. Then we calculate the uniform load, which is equal to total load applied over D. Then, the value of the shear force at D, or the section XX, is calculated. Finally, we can compare the calculated value of the shear force with the measured shear force by using the equation as shown. Secondly, to prove the superposition principle, we must first obtain the measured and calculated shear force at section XX for all 3-point loads according to the superposition principle. Finally, we need to discuss whether the measured and calculated value of the shear force obey the superposition principle.
Okay, hi! And for the second experiment is the bending moment experiment. Okay, as the proper use, this is the pivot, and this is for the load. This is as load, and this is as the beam, right? And first we must mark the position, mark points, which is this is for the point A, the end of the beam. This is for the point B at the pivot, first pivot. This is the point C at the second pivot. Is the point D, which is the section XX that we will measure the bending moment. Alright. Okay, for the first one, there are 3 cases that we will consider, which is the first case is the load is placed between the point A and point B. In the second case, we will measure the load will be placed between point B and point D. And for the third case, which is the last case, is the load is placed between the point D and point C. Okay, right now we're going to talk about the plotting the graph. Okay, we have 2 graphs, which is the first graph, relates the measured bending moment with the position of the applied load from the point A. And then for the second graph, which is relates the measured bending moment with the magnitude of the applied load. And then calculate the bending moments for all the loads that we applied and compare them with the measured bending moment values by plotting the 2 graphs that I said earlier. First of all, when the load is applied between point A and point C, that will be positive, which is we call it as a sagging moment. And then if the load is applied between point A and point B, that shall be always negative value, which is we call as hugging moment.
For this test, we will use this rod. These are the fulcrums and this is the XX value. At first, we will put a load at this W at this side, and then we will put another load P at this side. Now the distance here is measured. The value of P is calculated using the formula. And then theoretically we should have a moment of bending of 0 at this point. But we will get the experimental value and compare it with the theoretical value. In this test, we'll be studying the effect of uniform load at section XX. Single loads are placed at an equal distance from each other. The distance from this point to this point is called D. We'll be calculating the uniform load at D. Now, what we are interested in is the effect of this uniform load at section XX. We'll be calculating the experimental value and we will be comparing it with the theoretical value.
For the last part of this experiment, we need to prove the superposition principle. First, by using all of the data that we have collected from this experiment, we need to find the bending moment at section XX. How? By using this formula, we can obtain the reaction of RB. Next, we need to make a cutting at section XX to get this type of free body diagram and obtain the bending moment by using exactly the same formula, which is the total of MD is equal to 0. Lastly, according to this superposition principle, we need to discuss whether the bending moment that we have measured does obey the superposition principle or not. That's all. Thank you.